Welcome back. By now, this is clear. We cannot run container in the production environment, and we have seen Docker simplify the packaging the application. So we can write the container specification. We can run the containers, but it has many more limitations like scaling, self-healing, enterprise features, and all these are missing. I've also told you in the previous session, containers are not new. So Docker is not innovation. In fact, the concept of isolating apps and running them securely has been evolving over past 40 years. Yes, over past 40 years, and that's how people used to run multiple applications on the same physical server. Now let's take a quick look at history of containers, how it started, evolved, and eventually today we see as a Docker container. In 1979, first technology chroot come into the industry, and it was first isolation technique. Now we know what is container. What is Docker container? Docker container is isolated environment. Now you see this is not new, right? So these concepts already came in 1979, and using chroot we can create isolation of what? Isolation of a process. So chroot was introduced by Unix, which let you change the root directory of a process. Yes, so let's say if we have this maybe physical machine, a virtual machine, so chroot let you change root directory of a process. So if you have a process running over here, then it let you change root directory of this process, isolating it from the rest of the system. So we know what is process. If you are running any application or maybe any software inside a virtual machine, then this is called process. So what chroot do? Chroot change the root directory of this process. So this process has the root directory, right, from where this is running. So this isolate it from the rest of the system, means these systems really don't aware of, and it don't have the more control on this process because it has own isolation, it has own directory. Now you imagine this concept is not new, and same things we see in a Docker container. Now fast forward in 2000, FreeBSD jail technology came into the industry, and this was to secure container-like environment. Okay, so here we have been talking about isolating a directory, but now this is talking about isolating like a environment, means this is create jail as name suggests. So FreeBSD jails is create like jail for a process that isolate entire environment of this process, which includes its own users, file system, and most importantly IP address. Now you understand. So here in the chroot we were only isolating directory files. Now using this free BS jail, you can have your own user of this process, and you will have the IP address, and this is what we see in, again, same concept, same thing in a Docker container. Now in 2004, Solaris Zone technology came, and it was full OS level virtualization. Exactly. So now the way we run a virtual machine, so it was similar. So similarly you can run a process like a virtual machine, but only difference was its use the host kernel. Yes, so it's more like full OS level virtualization, but it is still run on the same kernel of the virtual machine or the physical machine where you want to run this process, you want to isolate it. So this you see, right, when we say what is Docker. So Docker create the container, right, and this is the containerized environment, and that container also use host machine kernel. So by 2004 this all things was there, right? So this is not innovation, that was my point. But as of now, you see, we are only whether it was chroot or FreeBSD jail or Solaris, we are talking about how to make a container isolated. But here you can go ahead and write some bash script, maybe some scripting, then you can make this process isolation. But there's no standard way of creating it, and that's where Alexei in 2008 came into the industry, and that was first Linux native container. Now it's started calling as a container, and it's given way to create a container. So Alexei made container first class citizen in the Linux, and it was as a name see Alexei Linux container. So it's only create a Linux container. Nowadays we can also create container on the Windows machine, but that time it was only possible for with the Alexei only on the Linux. But still developer, it was developer unfriendly and hard to manage. And then in 2013 Docker came, and it was more developer friendly, running a container. Right now we know what are different features of the Docker, so everything's got changed. But now let me tell you, even before Docker, using this chroot, FreeBSD, Solaris Zone, even using Alexei, people were running container environment. Now let me tell you, it was 2011. I was working for a company called Safest Technology, and we were building a platform called App 42 Pass, and it was platform as a service similar to Azure Web App or Elastic Bean Stack in the AWS. So what we are doing, we were giving a user to deploy their application in one click. So whether your application is Node.js, Java, Python, Ruby, bring your application in one click. We will deploy your application. And what we have been doing behind the scene, we have been creating container. And how we have been doing, and I said this was 2011. So we have used chroot, C group, and namespace. So using three technology, chroot, namespace, and C group, we have been creating our containers. And after couple of months, we realized it was very hard because we have been writing our bash script to create our own container, and we are managing our own way. We have our own couple of different modules to manage these containers. Then to create it again, we have done some more research. Then we come to know about Alexei. Then from our own bash script, we moved to the Alexei. Then we started using the Alexei to create the container. Now what here I'm trying to tell you, even before Docker, people were trying to use the container. Now let's talk this in more detail. This was my personal experience, but in the industry, people were trying to run the containers even before the Docker. How? In 2003, using the Borg technology, Google was running massive scale container. Yes, so Google was already running everything in container in 2003, like search, Gmail, Google Maps, ads, and everything they have been orchestrating using this this technology called Borg. And today, what we see as a Kubernetes, this is open source version of the Borg. Anyways, I will talk this later, but just to let you know, the way in 2011 we were trying to run our own container. So we were creating container using the bash script initially, then we use LXC, but to manage, monitor, scale for self-healing, we have written our own couple of modules that was taking care of it. And similarly, other company also doing the same, but container itself was not the way to run the production ready application. Now in 2014, when Docker came, and now you know limitation with the Docker, right? Because Docker is not production ready, so you have need some script, some way to monitor it, to scale it, to make sure it's able to self heal. So you have to write something. So in 2014, Amazon Web Services come up with the service called Amazon ECS, and they started running production ready container application on Amazon EC2. So they solve all this problem like running a container on the single host, self-healing, auto-scaling, also enterprise-grade feature they added in the Amazon ECS. So Docker came. Now with the Docker, it's become easy to create the container, run the container, but production feature was missing. So that's why that what I'm trying to make you explain, so you understood this, as you should understand importance of this. Now fast forward in 2015, Azure launched its own service, Azure Container Service. It was from the Microsoft. Then in 15, Kubernetes first got released. So Kubernetes comes from the Borg. So what Google did, Google modified their Borg, and some of part they make it as a proprietary, and some of the part they make it open source. So Kubernetes launched in 2015. So this is the again container orchestration tool to how to manage the container, right? So either you use a tool, or maybe you write your own custom script, okay, or maybe couple of modules. So here if you see, let me clear this, sorry. Well, so even before Kubernetes get released, so company were already running their production grade containers, like as you see, AWS has this service, Microsoft has this service. And then in 2017, after that, after 15, companies has started using Kubernetes as a tool to manage the containers. And nowadays, around in the container world, 80% of the containers are managed by Kubernetes. So 80% of the containers run using the Kubernetes, managed using the Kubernetes. So in the different form. So you see GKE. So what Google did in 2017, they launched Google Kubernetes Engine as a platform that's is running on the Kubernetes itself. 2018, EKS Elastic Kubernetes Service and AKS Azure Kubernetes Service got launched. And again, all these services, what you see, these were based on the Kubernetes, but this is managed by different cloud providers. So what I'm trying to tell you here, though containers was available, but it was not production ready. To make it production ready, we need a tool that can manage it. Well, now we understood companies were already running massive number of containers before Docker came. So Google was using containers at production from 2003 using this tool Borg. And what Borg do? Borg basically use Linux C group control group for the resource isolation, chroot, and later namespace for file system and process isolation. And these were low level Linux primitives. This is what we need, and this is what even Docker use. So that was from the Google, and other people's using their own custom script and custom modules. So this is one aspect of understanding how container evolve and what is needs of a container management tool like Kubernetes, though there is other tools available in the market as well. And we have seen AWS was using Amazon ECS, Azure was using Azure Container Service, right? But now as Kubernetes become open source and it's become more matured, so people shift their focus towards the Kubernetes, and Kubernetes is one of the best tool for managing the container in the production. Well, now this is the technical aspect of the Kubernetes and the needs of the Kubernetes. Why do we need Kubernetes? But there is another angle and another perspective as well. Age of microservices. Yes, so and this is the software architecture aspect. So in next session we are going to understand why Kubernetes become when we are running microservice architecture and when our application architecture evolve from monolith to microservice. Well, so that's pretty much for this session. In next session we are going to understand why Kubernetes become essential to run microservice architecture.